All right, I think it's time to get started. So I'm going to rock it. So, I'm Michael Stahnke. I'm VP of Engineering at CircleCI. I'm not going to stand up on that little stage. I'm going to talk about what the unit of work is in modern delivery. So over the last while, I've worked at different companies. I've been in the automation space for about 10 plus years, and so I'm really interested in kind of where this is taking us, what's going on, how we're managing what's happening out in the world. I'm at CD Conf, so there's a whole conference around doing continuous delivery, whereas 10 years ago that was not that common for a lot of places, we'll say that. But when you start with something like a unit of work actually comes from classic physics where you have a joule and all those types of things. But when a unit of work is really, you break something down into the smallest thing that completes a task. And so you just, you break things down. So you start with the outcomes. And what do we have with continuous delivery? Well, we want to deliver some user value. That's really the entire point of doing continuous delivery is users get to do something. They accomplish something. We measure that something. So that value runs somewhere. That somewhere has its own characteristics and its own user value that is being delivered by someone else, probably. That somewhere else has its own characteristics and its own work. So there's just a lot of different stuff that happens where you have I have it deliver a thing, it's on top of a thing, it's on top of a thing. These are all being delivered at different cadences by different folks with different people and different things. So in the past, a unit of work for a lot of the roles in technology was either a user story or a change ticket or a phone call or an email. It was just a, hey, I need you to do this thing. People would do that thing and they'd complete it. If you think about your cable person, when you call, they're like, well, my dispatcher says I got to do this, this, and this. That's their unit of work. Like, that's just how it works. So this was how it was. And it was different for different roles. In the operations world, change tickets or incidents were kind of the initiator. In other, in developer roles, it was user stories or just, tickets like that. So, but over time, we began to see convergence in that there was kind of one unit of work. It was a master system. But before we get there, I'm going to take you back in time to some of the things that I learned on how we got to what the unit of work is or what really makes us better at continuous delivery today or what enabled this. So I went to the first DevOps Days US in 2009. It was in San Francisco. It was my first time out in the Bay ever. It was amazing. It was at LinkedIn headquarters. They had like Frisbee golf going on in the back. It was just one of those places where I came from Caterpillar where they had just let us not wear ties. That was a big deal there. So it was a very different eye-opening experience. But what I got was there's this whole thing called infrastructure as code. And I had been friends with the guys who founded Puppet, and eventually I went to work there. You saw it earlier. But there was a couple other companies that were doing this infrastructure as code thing. And then a couple years later, you had some others pop in there. But infrastructure as code was this whole idea that we're going to do all this stuff that operations used to do, and we're going to do it like development. Okay, cool. So now I have a review of a thing happening. I can use this as a communication tool. It's all from code. And basically what this got us was auditability, accountability, reliability, understandability, all the ilities. And that happened because it was a pull request or a merge request or whatever it was. There was reviewing. I know what's going to happen. Instead of going to a change review board on Wednesday morning, sitting for 2 hours talking about something that's going to happen in 2 weeks, it could be, oh, here's some work. I'm going to hit merge. And if all goes well, it's going to be live. And then you got into the suicide commit territory where it was just like you hit merge and it went out there whether it was good or not. And that was super fun. But, we all learned. But now let's go back in time even further before that. How many of you ever worked with somebody who had a job title that was called a build master? Yeah, I did. And this was just the person whose job it was to keep the build running. Basically, there was a ton of maintenance, feeding machinery, all of those types of things. And it was just a weird job. It really kind of doesn't exist anymore, only it kind of does. They call them DevOps engineers, but they're basically build masters. But basically, it would pull things over a period of time, maybe, and then do some stuff. It would create your own. You had to build your own build system because one didn't exist. And then we got to this point where it was like this grand idea of we're going to have a GUI with a config. This was not better. And it wasn't better because now I have my work happening in one space, but I have my code happening in another. And so I have to maintain two systems, but they were maintained by two different people or two different teams. And so a lot of it was interesting in that Maybe there was code happening over here moving at one rate, and there was a build system happening over here moving at another rate. And when something failed, you had the big problem of, is my code bad or is the build system terrible? And the answer was usually yes. So you didn't know what was going on. But then we got into this pipelines as code, borrowing from the infrastructure thing as code, and it was, well, let's move how we talk about the work and put it right next to the work. And that was, all of this YAML, so much YAML. Please, everyone, stop it with the YAML. But there was so much YAML talking about work. So we have a pipeline defined, or we have a delivery, cadence defined, or whatever, and it's all in there with our source code. Cool. So now we have everything is code, right? We have the way we deliver, the way we test, the way we validate, the way we talk about it. Everything is code. Cool. Then we have some policy as code when you get into security standpoints and stuff like that. That's developed in code. So I can, again, do all those reviews, those merges, all the ilities I talked about earlier. That all happened. This leads us to some marketing guru calling this Git Apps. Cool. All right, we do everything with Git. I don't know why this wouldn't work with any other version control system, but it was called Git Apps. So now we have Git Apps. We make a pull request, we review it, we merge it, and things happen, whether it's about source code and applications, or it's infrastructure, or it's policy, or it's pipelines, or it's anything else. How many of you basically run a Git Apps workflow today? I'm so curious what the rest of you are doing, but okay. So we all basically did a whole lot of YAML. And if you can't tell, I'm not a YAML fan at all. It's a weird specification. Norway and no and false are all the same thing in YAML. It's really weird. But what the problem is everything that I just described is code. It's all happening as code. So we're like, okay, everything is code. We have all these little building blocks, and that's what we deliver. And that's what we push across the system. Code. And there's a desired convergence that everything ends up being code, which is cool. And in this world, the unit of work is a commit. A commit is the thing that you can divide all your work down, validate it, see if it's good, make it happen. Some might call it it's a pull request. If you have many commits in a pull request, we can all debate hygiene and all that stuff. But anyway, it's a commit, more or less. So you have a commit moving across a system that has been detailed and built out so that you can validate everything that's going to happen on the other end because you know everything that's going on in your environment. Cool. We put all this effort in because we want determinism. We have determinism in that we know, given this set of inputs, we will have this set of outputs. Bad things can't happen because we validate it. I understand things because I review it. Cool. Cool. Cool, 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 cool. So, how many of you run Docker in any regard? Yeah, pretty much everybody. Let me give an example of, just hypothetically, something that could have happened. Let's say you have an ELB, and usually you have about 5 nodes behind it. A bunch of traffic happens, and it spins up 10 more nodes. So now you have 15 nodes. But when those 10 spun up, part of their bootstrapping process is they run Docker pull. They run Docker pull, and it grabs a thing called latest. What's latest? Yeah, I don't know. I have no clue what latest is. Thanks, mutable tags. So it's a different version. My application doesn't behave the same way on one version of this image versus another version. So 2/3 of the traffic going to my application is now hitting a non-deterministic endpoint, and the other third is hitting the thing that it was exactly what I thought it was that I had validated. Cool, 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 cool. So some of these instances are less good than others. My end user value is now not as great as it once was. And so I accidentally upgraded to a new version of something because I hit Docker pull and we didn't pin our version properly because latest is a thing. We'd always want the newest stuff, right? We're developers. Has this ever happened to anybody else? Ever? No? All right, I'm the only idiot. All right, cool. Cool. And then you get into, well, I validated a whole bunch of stuff, but did I actually validate it all? I had the same set of inputs. But then you have to ask yourself, did I really have the same set of inputs? And when I always think about, did I really have the same set of inputs, I come back to this Mario Brothers thing. Who grew up playing Super Mario Brothers? Anybody? All right, maybe I'm a little old at this point. But so if you ended the level when you jumped on the flagpole and the last number in the time was a 6, you got 6 fireworks. If it was 3, you got 3, and if it was 1, you got 1. If it was any other time, you got 0. To test this, you had an input of time. Anytime you run a build, time has changed. So my inputs, by definition, are not the same as what they were the last time I ran a build. Just saying. So we get into this whole, I want determinism. I'm all about determinism. And if you actually read like the psychological definition of determinism, you inevitably end up reading about free will, and do we all have our own free will or not, beyond the scope of this talk. But generally, most people think we do have free will. And so I have free will, but I have this whole thing that I have this whole God complex that I can be totally deterministic in what's going on in my CD pipeline. Cool. Basically, we have all these inputs. Does anybody understand them all? No, they don't. So requiring knowing all inputs to the system is how we get to determinism. We have to know all inputs. What else required knowing all inputs to a system to make it work? Yeah, waterfall development, which I thought was the whole thing we were trying to get away from doing CI and CD, was we were going to do these iterations and we were going to do it really quickly because I didn't know all the requirements up front. Waterfall totally works if you know all the requirements up front. I can tell you that. Like, it's amazing. It's actually a really good delivery system if you do actually know all the inputs up front. Very few cases in the world do you ever know all the input up front. So I get back to this, okay, so source code is instruction for operations and change and all this stuff, and that's why I'm validating, and then I start thinking about it more, I'm like, oh, no. Source code is for intentional change and intentional operations. And you can say, well, Mike, I've written many source codes over time, and they are sometimes very unintentional in what they do. And yes, that is happening, but there's at least a log that you made a change. There was intention to change something. There's a commit that said, I changed a thing. Maybe it didn't do the thing you thought it did, but at least somebody's like, oh, something happened, let me go look into that. So code implies desired behavior. You know what the behavior is supposed to be, you're trying to change it. And then you get into like unintentional change, and what type of change is not from GitHub? Well, there's all this stuff that happens basically post-code. Whether it's running on someone else's computer, using someone else's platform, someone else's payment gateway, someone else's infrastructure. Users go do different things. You get a post on Hacker News and now you're getting 800x the traffic you actually planned for. All of that stuff can happen and it's different inputs into your system. So those all affect technology delivery. My example with that ELB, I had traffic that caused me to get 10 more nodes. I had an image that I hadn't pinned appropriately. It grabbed a new version of a library that I apparently hadn't pinned appropriately. Who pins all packages inside their Docker images? Literally nobody. They all run apt-get update, then they clean out their app cache because they don't want it in the image, but they have no idea what versions are there. And Docker just came out with a way to do a BOM on an image like, what, 2 months ago? So there's just a lot of stuff there that's not that deterministic. So this is kind of all the stuff that goes into building an application these days. You have third-party apps, you have, just different infrastructure, and most of this isn't something that everybody keeps in their own brain anymore. It's like outsourced to different providers or to different teams or whatever. You don't know what's going on. So developers pull apart all of these things. They put it together with their own open source software libraries, the things they build upon, and the operators are doing stuff. And so you get this like little Tetris game of like, here's how I put together an application. Cool. Except did you actually validate all of that stuff? And you probably didn't. And so that's why you have incidents. That's why you have outages. That's why you're up at 2 a.m. or whatever the classic monikers are these days on carrying a pager. But we spent all this time building pipelines to validate what was going through. All this time. And we move code through the system at a super rapid rate. We are shipping all the time. We validate all of it. We validate most of it. We validate some of it that's going through the system. Well, what else is there? Well, CI is for a bunch of things that I know about. I can write tests. It should do this, it needs to do this, I wish it did this, it's supposed to do this when this happens, given this set of inputs, that's what comes out. Integration. Maybe I have a build, this library links to this, I can validate they link together, all of those types of things. CI. We've been here for years. CD. Things I can define as out of bounds. I'm going to deploy this to 4% of traffic. If it gets an error rate higher than 10% over the next 5 minutes, roll it back, all of that. Those are still pretty advanced features for a lot of players. But you can do that, and you can say out of bounds is when errors are this high. Out of bounds is when traffic stops going to this, or 500s, are at this. You have an out of bounds boundary. Yeah, I didn't like the way that came out. You have an out of bounds boundary. Yeah, quote me on that. But then you get into the actual user experience, which is reality. What's really happening? Because the user is the only thing that can tell you if it's behaving or working the way it's supposed to. All the monitoring systems in the world can tell you, you think you know, but do you know? Users can tell you for real. So we have all these applications. We build, we test. Maybe we pull in some of these third parties to even do tests, or we mock. We mock a timestamp change, or we mock out a library or a platform or whatever. And you can all get into the reasons mocking is great or not, into why you do testing. But then you deploy this one piece of code, and it goes out into the world with all of these wild things happening. Cool, 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 cool. So we have inputs where we build, test, deploy, release, and we have users. And frankly, the only thing I care about in this entire picture is what the users think, because the rest of it is just ways to get the user better stuff faster. So we have what's right in tests. I can define behavior. We have what's wrong in deploy, what's out of bounds. What's left? Well, I guess that's happening in the release and the user space. What's right, what's wrong, what's left? What the hell's going on? Yeah. So what we have is just a whole bunch of sources of change coming into this system. And some of them we actually kick off a build for, but a lot of them we don't, because we don't revalidate and we don't pull in all those things we rely upon. And that's modern complexity. And we still have these consumers of change. So in this world, there's change happening all the time because of the complexity of these applications, but we're only validating it a portion of the time. And in this world, the unit of work is no longer the commit. It's all the changes happening around us. And that's actually why we want to do CI, why we want to do CD, why we want to do delivery out to users, is to get this change through as fast as possible. And change can't always be code. Because if you run on a load balancer, and a load balancer spins up new nodes, there was no code change to review to do that. It didn't happen. It just happened out in the infrastructure world, and maybe I needed to react to that. Maybe I can make more things deterministic by saying pin my Docker versions and pin my packages and do all these things to make it. Yes, you can do that, and it's safe, and you should do those things. You will not know all the inputs and the complexity of your system. Your payment gateway suddenly decides that you are no longer taking payments from Russia. You had nothing to do with that decision. Nothing. What do you do about it? Well, maybe you need to revalidate some things. So, intentional and unintentional change. Unintentional change happens constantly around you in modern application delivery because we've built on these complex layers of platforms and APIs and gateways. So we basically have a streaming amount of events that are happening, change events, just changes happening all the time. Right now, nobody's really capturing those events, and they're all getting thrown on the floor because they're basically not even really emitting to anything that you can capture and play with. The way you find out about it is one of your developers says, hey, our payment gateway no longer accepts Russian stuff going through our payment gateway. Cool, that was not on a syslog that I could read or an RSS feed or anything like that. That just happened. So there's a bunch of events. But now let's think about how do we turn this around and say, well, if I know that change is the unit of work, what do I do differently? What do I do differently? Well, maybe I can start thinking about, can I start validating before a commit? If the commit isn't the thing I actually care about anymore, can I validate earlier? Cool, make some changes, it updates your IDE, maybe it runs unit tests in the background. Some people have done this for years. Some people don't. Can I do it on somebody else's computer? Can I be like, okay, just submit this over to CircleCI or submit this over to your other CI system or whatever while you're just editing? Cool, you can, sure. You can get release time feedback of, okay, this deployed out to 10% of nodes, 5%, it's got this error rate, all this. Okay, well, let's get all that in a change stream. Let's get that all captured, centralized. I can get runtime feedback, and you're like, hey, isn't this just monitoring? Yeah. Monitoring is just running CI in production. That's all monitoring ever has been. Run some tests, red, green, alert, same thing. We have upstream changes, new version of React, new version of Rails, whatever. I have a new version of something, everything changes. The system is not a controlled environment, so determinism isn't possible. If I feel like I'm hitting the same point over and over again, it's only because I am. I have my little piece of code, but my little piece is a small piece in all of that. But we have to think bigger. So now there's power in a network effect when you start to think about change. And this is something that we had with one of our big open source customers that uses them. We'll call them React, just for examples. React wants to know, when we release a new version of React, I want to know if these 20 projects have problems. Because they're the 20 biggest users of React, basically. And if they have problems, we want to stop the release. So what we'd like to be able to do is actually run their pipelines with our new version of React before we ship it. That's pretty cool. We're trying to make that happen. Like, that's awesome. So that's change before the change. Like, before you receive the change, before the change happens to you, somebody's proactively thinking about how that's all going to work. But it's a network effect. It's not something that you can do just one organization doing their own CI. You have to share this and make it better because we're all doing it together. We have bidirectional validation. Okay, that's a bunch of 20 orgs giving React a bunch of feedback saying, here's how it works when you have a new version. It worked for me or didn't work for me, or I had to change this config or whatever. But basically, you control only a portion of what your user experiences in the end. You have your code. That's what you control. But on top of other people's code, their libraries, on top of other people's computers, AWS, on top of somebody else's network, AWS, and your NPLS cloud, and AT&T, and Level 3, and all the people that are providing all these networks all over the world, on top of other people doing stuff that you don't even know what it is. You want chaos engineering? Put real users on something. That's chaos. They will do crazy, crazy stuff. So just keep zooming out, though. You have a path forward if you can take a change from anywhere and react to it. Code is all we've been talking about from this unit of work being a commit. Code is this small thing over here as to what modern application delivery is looking like. So I'm asking you basically to shift your thinking from code to change. It doesn't mean you're going to change the way you work tomorrow. It doesn't mean you're going to change the way you talk about that next PR review or merge review or whatever. But I want you to think about how there are so many inputs into your system that are not the things that you're trying to be deterministic about. There's so much more than that. It's all change, and the unit of work is change. We're trying to get change through the system. Is it CI? Is it CD? Is it monitoring? It's event-driven validation at this point. We have event streaming, and we need to validate. I want to be able to absorb change, react change, deploy change, create change. Those are all the things I want to do. Continuously be validating. Trigger things back in from what's going on in release, what's going on in monitoring, what's going on with my upstream vendors, my suppliers. I need like an internet weather report, and I need to react. That's how it's got to work these days. So we do all this because we want to automate confidence. That's what actually CD and CI is. It's confidence automated. I want to be confident that this thing works. And automating human emotions is really, really difficult. I keep trying. I've been doing it for 10 years. I'll do it for a while longer. But we keep trying. But confidence in these changes is actually what matters. So that's the end. This is really just a big picture, big thinking thing of like we go from commit to change. And that's all I'm asking you to do is change the way you're thinking about this. Anyway, I'm Mike Stahnke. I'm at CircleCI. Thanks.